Alright, on to number 2. So here we have some dichromate and some ethanol turning into some chromium and CO2. And remember, the first thing we're going to want to do is separate these into our half reactions. So we're going to have the reduced reaction, which will be gaining electrons, and you're going to have the oxidized half of the reaction, which will be losing electrons. And just looking at this, I know that the dichromate and the chromium will want to go together, and that the only way you're going to get chromium is if you've reduced something to get it. So that means that for the oxidized reaction, we're going to need to have the ethanol and the CO2. So first, let's just check all of our elements aside from the oxygen and the hydrogen. So right here we've got 2 chromium and only 1 chromium over here, so we're going to want to add a coefficient there. And down below we've got 2 carbons, 1 carbon, so we're going to need a 2 over here as well. Next we can go ahead and start balancing the oxygen. So let's start up here. We've got 7 oxygen here, so let's balance that by adding 7 H2O to the right side. Now we have to balance this hydrogen. So we have 14 hydrogen on the right side of that equation now with the 7 and the H2. So we're going to have to add 14 H plus ions on the left side of the equation. So now the top should be all balanced in terms of the elements. Now let's look at the oxidized half reaction. So let's see. We have 1 oxygen here and 2 oxygens here. Oh, sorry, that's multiplied by 2, so we actually have 4 over here. So in order to get 4 on the left side as well, we're going to need to add 3 H2Os. One sec, I'm going to give us a little more space. Okay, so we're adding 3 H2O over here. So now we need to balance out the hydrogens on the bottom. So we have 6 over here. We have 5 and 1, so that's another 6. So we have 12 hydrogens on the left. So we need to add 12 hydrogens on the right. Okay, so now all of our elements should be balanced at this point. Now we can move on to balancing electrons. So let's start at the top right here. We've got 14 plus here, 2 minus here, giving us a total of plus 12 for the charge on the left part of that half reaction. Now here we've got 2 and 2 of the 3 pluses, so we've got 6 plus here, and the water molecules aren't doing anything, so we have a total of plus 6. So in order to balance that charge, we're going to want to add 6 electrons, sorry there's not a lot of room over there, to the left side, and that gives us a balanced charge of 6 on both sides. Okay, now let's look at the bottom one. We actually have no charge on the left side for our oxidized reaction, and over here that has no charge. Here we have 12 plus, so we have a plus 12 charge over here. So the way to balance both sides is going to be adding 12 electrons to the right side, because that gives you 0 on both sides. Okay, so now both of our half reactions have had their charges balanced, but now if you look, we have 6 electrons over here and 12 electrons over here, and we need those numbers to be the same so that they'll cancel out when you add everything together. So we're just going to multiply this top part by 2, because that'll give us 12 electrons on both sides, and that will allow us to cancel them out. Perfect. So now you can go ahead and add everything together. Just make sure to remember to multiply everything by that coefficient there at the beginning there. Okay, so I didn't have enough space, so the left part of the reaction's on the top and the right part of the reaction's on the bottom here. So you're almost done. At this point, all you need to do is kind of check if anything can cancel out. So it looks like we actually have hydrogen on both sides here. So you can cancel out 12 hydrogens from the right side of the equation and bring that 28 down to a 16. Then it looks like you also have some water molecules here and here. So you can completely cancel out those 3 H2O's on the left and change that 14 to an 11. Alright, let's clean that up. Alright, so that should be our final answer, and all that's left is to just double check that all of our elements balance out and that all of our charges balance out. So let's see, we've got 16 hydrogens. Oops, sorry. We've got 5 here and 1 there, giving us 22 hydrogens there, and then over here we have 22. Checks out. Okay, so here we've got 4 chromium. 4 chromium looks good. Over here we've got 14 oxygens, 15 oxygens, and over here we have 11 and 4, giving us 15 oxygens. Excellent. And finally 2 carbons here and 2 carbons there. Okay, all of our elements check out. Let's check our charges. Okay, over here, let's check our charge. We've got 16 plus and 4 minus, giving us 14 plus over here. Oh, sorry, bad algebra, right? That's 16 plus 4 minus, giving us 12 plus over here. And then on the right, we've got 12 plus. Checks out. And since this was also in an acidic solution, we can stop at this point. Again, if it were in a basic solution, it would involve a few extra steps. But right now, we can stop right there, and that is our final solution. Thanks for watching.